Okay, hi everyone. GM, good evening, good day, wherever you're watching from. Yes, and you're welcome to the last class, the last session of the Cairo Bootcamp 5. It's been a good ride so far. And this last class, we're going to be having truths. It's going to be taking us on testing and smart contracts. So it's very important that you know how to test your smart contract. You don't just ship out smart contracts just like that. You have to test it before it goes live, right? So I'm just going to hand over to him. So we start the class. Thank you.
Okay, thank you very much. Good evening, everybody. So like she said, my name is Truth, um, Starknet developer. So today we'll be looking into testing. So testing, we all know that smart contracts are like very delicate. You need to handle money and all of that. And whenever you write contracts, you want to make sure that you have tested them thoroughly. You understand? So most of this class, it will be live coding. You understand it? Like there is no slide to follow. It will be live coding, and at the end of the class, I'll provide the repo to the code that we have written and the resources. So let's start. Let me start by sharing my screen. Mm, Yeah. I'll have to quit and reopen Zoom to share my screen. This is my first time using it on this laptop.
All right.
Yeah. So let me share my screen now. Um, yeah, can everybody see my screen? Maybe if you can see it, you can give like a thumbs up or something. Okay, thank you. Yeah, so we have a project here. Sorry. So we have this project here. It's a basic counter contract, but with some additions. So the first thing I want us to do is let me just walk you guys through what we have here. We have the interface here, and then we have the contract here. This is the stack token on Sepolia. We have our storage here, the counter. So basically a counter project, what would you be doing is incrementing counter, adding one, decrease it, you increment, decrease, and maybe reset. And this is the admin. For some reason we have the admin here, and we'll understand the reason soon. And we have this reward amount. So, and we have our events here. Um, we have our events here. I believe everybody here is familiar with these concepts, all the concepts that we have here. So, and next thing we have is we have the constructor. So when we deploy, we are setting the reward amount to 0. We are passing a counter initial value, and we are passing the admin. Again, we'll soon understand what the admin is supposed to do. And we have the contract implementation here. So the first thing is increment. Um, as you can see this, anybody can call this increment. And basically what it's doing is incrementing the value of the counter by 1. And then once we are done, we emit an event to show that the counter has been incremented. And if you look at the second one, decrement, basically, and if you look at this check here, we don't want to underflow because 0 minus 1 will give an underflow, and the counter cannot be negative. So if the counter is 0, we want to revert. You understand? And then we calculate the new value here, and then we update it. Then we emit the event. Now there is one extra step that is here. So if the new value is 0, we want to reward the caller. So we are basically like gamifying it. You understand? So if the reward is 0, we want to reward the caller. You understand? And you see that we have an ERC20 token dispatcher here. So we are using the stack token address, and then we are transferring from the contract to this winner. The winner is the person that called the function, and we are giving them this reward. Then we emit an event. And if you look at the reset, you see one access control here that only the admin can call reset. You understand? Only the admin can call reset. And whenever the admin call reset, they can call reset with a certain amount. That is, they are transferring some stack token to the contract. And yeah, transfer from the caller to this contract and this certain amount. Then we emit the counter reset event and the contract funded. Then we have these two get functions, the get counter and the get reward amount. So with what we have in this contract so far, I believe you guys have done writing contract and a lot of things, and I believe you guys pretty much understand pretty much everything that we have here. Is there any question regarding the way this counter contract is written? Does anybody have any question? Let me check the charts. Yeah, sorry. Okay. So basically, so the reason why I'm adding this stack token is because there is a particular test I want us to do, which is called fork testing. So fork testing is you can fork like the mainnet and do test directly on the mainnet. These transactions won't reflect on mainnet, you understand? But you can simulate the state of the mainnet chain. You can do it for Sepolia as well. You understand? And so that's why we have this stack token, because we actually want to make transaction. If you look at these transactions there, for decrement and for reset, we'll be using the fork to simulate transaction on Sepolia testnet. Can everybody hear me? I'm coming to look at what I'm sharing. Maybe I should share this alone. Yeah. Can you guys still see the VS Code interface right now?
Yes.
Yeah. I'm so sorry, like I'm not at home, so I don't have like the big screen to be seeing what's happening in the chat and this at the same time. So yeah, we have the contracts already implemented. So the next thing we want to do is we want to test. And the people that are here that are familiar with Solidity, you know that there's something called Foundry, which you can use to do Solidity testing. So Foundry is like a framework that you can write Solidity tests directly in Solidity. The way we normally test Solidity before Foundry is you do it with JavaScript or TypeScript in ADAT. But with Foundry, you can actually write the test in Solidity. So the Foundry team, they have like a framework for Starknet also, and it is called Starknet Foundry. You understand? So the first thing you want to do is this is our source folder where our contract is. Then you have a test folder here. You understand? So let's take, for example, that you want your test to be in this source folder. You need to do something like this CFG test. Then you can do pub mod test. Then you write a test here. You understand? But this is not very good because you are basically writing tests where you have your contracts. So we want to have something like separation of concern. So we have this test folder. When you run scarp new, it automatically generates the source folder and the test folder for you. You understand? So, and I talked about SM Foundry the other time, Starknet Foundry. So if you look at the scarp.toml file, the first thing you need to do is you need to add SNForge. So for the version that I'm using Starknet 2.15.0. And in the dev dependency, you have to add SNForge. So in most cases, Starknet do have like all this and these packages they might not be compatible, but this version of Starknet and this version of SNForge, they are compatible. You understand? So, and then we have this assert macro. So basically what this assert macro allows us to do is, so instead of just doing something like assert, we can do things like assert equal, you understand? So we can do things like that. So that's also like a dependency that we added. And we have OpenZeppelin. OpenZeppelin is actually for this. So we can access the token interface and call functions on anything that has to do with token. So let's start. Let's start with writing. And if you look at this, the first thing we want to do is we want to deploy the contract. Because before you can test the contract, you need to deploy it first. You need to deploy it first. So the first thing we'll do here is let's write a deploy contract function. So this will take an initial value,
Hello,
which is
sir.
it. Hello?
Yeah, the
Yeah.
code you're using, do you have like a GitHub link to it?
Yeah, I have a GitHub link. You want to be seeing it live right now?
In case some of us want to follow, so that
Yeah. Let me share a link in chat so you can see this. I was thinking I would share it after the class before. Thank you for reminding. So you can see it here. Oh, this is like the test file. So let me send the whole thing. So the name is a little bit odd. And it's so long. Yeah, but that's it. You can clone it. You can clone it and check the repo there. So yeah, let's continue. So we have this deploy contract, and when we deploy the contract, what do we want to return? We can return the contract address, right? Or let's write the function, or the best thing would be to return the dispatcher trace for the counter interface. You understand? So let's do I counter dispatcher. You understand? This is automatically doing the import automatically. You
Sir,
understand?
can you increase your fonts too?
Okay, sorry about that. Is it okay now? Or should I increase it more?
It's okay, sir. Thank you.
All right. So the first thing we want to do is we want to use SNForge to deploy these contracts. So let's use SNForge. There are some things that we need from SNForge. You understand? The first thing is the contract class traits. We need this contract class trait because we'll use it for deployment and for declaring the contracts. For Starknet, there are like two stages. You need to declare and then deploy. And yeah, I think we have this declare function also. Yeah. So the first thing is we have this let's write the contract class. This is equals to, we want to declare this, and the name of our contract, if we come here, yeah, the name of the contract is this. Then you want to do an unwrap syscall dot contract class. So this is the contract class. That's the first thing you need to do. And for deployment, the next thing you need to do is so the way things work in Starknet is that everything is a felt. You understand? Everything is a felt. Now, if you look at felt, it has 252 bits. So if you look at numbers like U32, they fit in that range. But if you look at some things like string, or you look at numbers that are like U256, they don't fit in that range. So when you are passing arguments into the constructor, you need to serialize them. So we have contract addresses, so you need to serialize them. So the next thing we need to do is we want to declare the constructor called data. This will be an array. And now we have the initial value, we are passing it here as an argument. So this is how you can serialize it. Just do initial value dot serialize and pass the constructor called data as a reference. So for some reason, the intelligence is not working. Now, if you look at this constructor, it takes in two arguments. So the first one is self. We don't need to worry about that. The initial value and then the admin. So whenever you're writing tests in Starknet, it is always advisable for you to declare some constant, like addresses you'll be using. So let's define a constant for the admin. We can do it like this. Just do it at the top of the file, so you'll be able to access it anywhere else. The contract address equals to, let's just do admin. Now, if you look at this value is a felt. So we need to convert it to contract address, then unwrap. So for us to pass in the next argument, so the order in which the argument shows in the constructor, that's the order in which we serialize them. So the next thing is we do admin, the serialize ref constructor call data. You understand? And once you have this, the next thing you want to do is you now want to deploy. You understand? So let's say let come in. I will explain because this will be returning two things. So you have the contract class dot deploy. You can deploy, and then you pass the constructor call data, and say unwrap syscall. Understand? And this will be returning it will be returning two things. The first one will be the contract address. You can ignore the second one. So when you ignore the second one now, you notice that we want to return the iDispatcher traits. iDispatcher, iCounter dispatcher. So we can do this. So the contract address will just be this. We don't need to do anything. So, so this is a function that will deploy the contract. You understand? This is the first thing you want to do when you're writing an SMForge test. You write the function that will deploy the contract. Because in each test, at the beginning, you want to deploy the contract and then run some tests on it and say that everything works as expected. You understand? So we have our deploy contract. Does anybody have any question here? Let me check the charts. Is there any question? If there is no question, then I would say we continue. So the first thing we need to test, we want to test is what? We want to test that the constructor actually works. You understand? So let's say fn test deployment. You understand? FN test deployment. So for each test function, you need to add this. So it will recognize it as a test. So how do we test the deployment? That's just like very simple. We know when we call the deploy contract function, it should return a counter contract. Let's just say contract equals to deploy contract. Let's pass an initial value of 0, right? Let's pass an initial value of 0. Now we have this contract. Now, when we deploy, what states do we expect the contract to be? The first thing is when we deploy with initial value of 0, the initial value, whenever we get it by getting the counter, when we get the counter, we expect it to be what? 0. And during deployment also, the reward amount should be what? 0. And the admin should be this address that was passed. So let's check all of that. So we can say we now want to do some asserts. You understand? So the first thing is we want to say contract dot get counter equals to 0. You understand? Okay, we are getting an error here. So the error is because we don't have the I counter dispatcher trait. So let's yeah, we have the I counter dispatcher trait now. And the second thing we need to do is we want to check contract dot get reward amount. That should be what it should be 0 as well. So let's put some message invalid counter. Let's say this is invalid reward amount, right? Yeah, we do have this function. Sorry, this should be 0. And the last thing we want to do is to check that it is the admin. Now the admin address is actually equals to the admin. Do we have a get admin function here? No, we don't. So let's add it. Get admin. Should return a contract address. Not admin.read. So let's put it in the interface. Okay, we don't have the Starknet contract address. Yeah, so I think we are good. So let's do contract.get admin. That should be equals to this constant admin that we have at the top. Invalid admin. Yeah, so let's test this. Now, for us to test this, we can run snforge first. So make sure you have snforge installed or make sure you have Starknet Foundry installed. Yeah, and we can see that the test is passing. You understand? So let me clear my terminal and do that again. snforge. So another way you can call the test command is you can call it using scarp, but you must make sure that you have this configuration in your scarp.toml. This means that whenever you run the script test, it will run snforge. So if you run scarp test now, it is basically the same as running snforge test. So I hope that is clear. Does anybody have any question regarding the first test that we did? Is there any question? I don't think so. Yeah, so let's continue. Now we have functions here. We test the initialization that whenever we deploy a new contract, everything works fine. It's working as expected. So the next thing you want to do is you want to test all functionality. You understand? And the first functionality we have here is increment. Let's see whether when we increment the counter, let's see what will happen. So let's write a new test right now. For those that are following along with the one on GitHub, this might be a little bit different, you understand? I've prepared that. This might be different. This might not contain like the exact same thing because I'm doing this off the top of my head right now. So, so we do things the same way. You can even copy this code and say, let contract equals to deploy contract. Now, the next thing we want to do is want to say contract dot increment, right? Now, when we increment this, what do we expect to happen? According to the logic that we have here, the increment should increase the counter by 1. So let's do the math here. Initial value before we call increment is what? Before increment equals to 0, right? And when we call increments, what is the expectation? What do we expect? Sorry. What do we expect to happen? So what we expect is after calling increment, we expect the counter to increase by 1, right? That is 1 plus 0 plus 1 equals to what? 1. So that is after calling increment, when we do the get counter again, we expect it to be what? To be 1. So we can use our assert. We can use assert to assert that. Okay, contract dot get counter equals to, let's say, invalid counter here. Right. So let's do the scab test again. Now, let's say let's assume that the value that we passed in here is 10, right? What should we be asserting here? Yeah, can anybody send the answer in the Zoom chat? Or you can say it, you can.
11.
We are expecting it to be what? 11. So we put 10 here. That is 10 plus 1. That should be what? 11. Right? And it is passing. Let's put 10 here, or let's leave it at 1. Let's leave it at 1 and see what happens. So it is saying invalid counter, which is the message that we put here that the counter is invalid. It is expecting it to be 11, but we are getting what? 1. And that is invalid. You understand? So, yeah, let's return this to 11. Now, if you look at it, there are lots of things that is happening in the increment function. The first one is the state change, right? And the second one is what? Can anybody tell me the second thing that is happening in the increment function? You can unmute and say it.
Emit, like the state change, then it's emit.
Okay, so we have the state change, and then we are emitting an event. Yes, thank you very much for that. So what we are doing here, we are basically testing the state change, right? But we are not checking whether the event is being emitted correctly, right? So the way to test the event, it's not it's so we need to import something here. We need to import this by event function, and we need to emit this event assertion straight, because we'll be asserting, we'll be making some, sorry guys, we'll be making some assertions on what the event is, you understand? So now, for us to do this by, the first thing we need to do is we say, maybe after we have deployed our contracts, we say let mute spy. It has to be, then we call this spy function, right? We call this spy function. We call this spy function. Now, you see that we are putting this at the top right after deployment, right? You'll see the reason for that very soon. So now after checking this, we want to assert the event. Now, what is the event supposed to look like? Let's say, let expected event equals to, what event are we expecting? Let's go into counter. Let's do it here. What event are we expecting? We are expecting the counter incremented event, which is this. So we have to import it in our test, right? So we do counter, and then we say counter incremented, right? Now, we say counter incremented, the value we expect it to be is what? 11, right? Now, for us to test this event, we just do this spy. We have the spy variable already, spy dot assert emitted. Now, this spy dot assert emitted, you can hover over this and see the arguments it takes. If you look at this event, it is taking snapshots of an array. Now, this array is contain tuples. The first tuple should be the contract address, the contract that we are testing the event on. And the second one should be the actual event that we are checking. You understand? Now, in this case, we can do something like at array. Let me do this. So yeah, I'll still put the at. I was thinking the thing will work in the autocomplete. Now, we have to check, I mean, it depends on how many events you want to check. But in this case, we have just one event. So the contract address that we have here is, just call our contract here, dot contract address, right? And call the expected event. Yeah. So that means we are asserting that whenever we call increment, we want to check that it's emitted that particular event. Let's check. Let's run scarp test and see what happens. Okay, yeah. So we are getting an error here, right? We are getting an error. And let's look at the logic that we have here. Let's look at the logic. So counter incremented, and then counter incremented, and we have the value, new value. So the new value here should be 11. The new value here should be 11. Yeah. Okay, I think I found out what the error was. So the thing is, the issue was that we are basically testing, we are checking this struct. But what we should be doing is we should check the enum that is defined here. So let's do event. This. So yeah. Okay, yeah. So basically, we say count incremented. And then I'm trying to check. Yeah. Incremented. The names, they look alike too much. I don't know. Let's find a fix for this. So instead of doing this, let's just put the event here. And then let's use this namespace. And we don't have this as well. Let's look for this. Yeah. Sorry. Everything is a little bit messy right now. So I'm just calling this struct and then checking this event. I hope you guys get what I'm trying to do. So because this is an enum, we actually need to check on the enum, not just the struct, but this enum contains the struct. We need to check on this enum variant, which is counter incremented. So let's run the test again and see what happens. So it is saying the event, it is saying the test passed, right? Let's try to check and let's change this to a value, let's say 12, and see what happens. So you can see event with matching data and keys was not emitted. You understand? So that's because the event, it is emitting with the value 11, but we are passing 12. We are expecting it is emitting 11, but we are checking with 12, which is very wrong, right? So the test will fail. So on the aspect of event emission, does anybody have any question? Okay, think. Okay, someone said 11 or 10.99 due to inflation. So, yeah. So what's the next thing we should test? Decrement, right? We should test decrement. Let's see if the value actually decreases. Sorry, please wait a minute. Sorry guys. It's these people. So the next thing we want to check is decrement. If you look at the decrement logic, it's a little bit complex. So the first thing we are doing is we are decrementing and updating the counter, then emitting the event, and then we check if the new value is 0, because any user that can get it to 0 should get a reward, right? So we have this. So let's test the decrement. FN decrement. So yeah, okay, yeah, there is something I wanted to do. Let's take, for example, we put this pi. Let's say we define it before the function was called. Let's see what happens. The test will fail. So whenever you are using SPY, you must make sure that you have defined it before the action that you want to test, before the event is emitted, because what this SPY is doing is it will be checking any event that is emitted and it will store them somewhere, you understand? And then you can check that a particular event was actually emitted. So it is very important. For me, the way I do it most all the time is after deploying the contract, then I turn on the SPY. You understand? So let's go with let's start with decrement. Yeah. We have pretty much the same thing here. Let's just copy it. Now, let's call decrement directly. Let's say contract dot decrement. This should fail. Sorry. Yeah, this should fail. Can anybody tell me the reason why this is expected to fail? Why we're expecting this to fail? So
Okay.
yeah,
Okay.
go on.
Okay, because in the that's lib.cairo file, right? There's a check already that if is less than 0, that it should fail.
Yeah, exactly. Exactly. So let's try this and see what happens. We are expecting this to fail. And yes, it failed. You can see fail, test, decrement. So one thing is when you are writing tests like this in Cairo, you can say you are expecting something to fail. You understand? So let's do the same thing for this. I don't think we need this. We don't need this. So we can say should panic. You understand? Should panic. The expected should be what? What is the value that we have here? Yeah, counter cannot be negative. Yeah. Unsupported attributes. So this is not like it's not like there is an error. I think it's something with the compiler. Let's check this. So we are expecting this to panic, right? And you can see that 3 are passing because we are expecting this to panic and it did panic. So when you are testing, you are testing for success. You should also test for failure. That this thing is expected to fail here, and it did fail. So let me change the name of this to test decrement should panic. Let me copy this and then write the next test. We are not expecting it to panic here. And you see that when we put any value that is greater than 0, things should go fine. Let's turn on our spy here. All right. Let's turn on our spy here. Now, let's do something. Before decrementing, let's get let counter before decrement. Let's say contract dot get counter. I'm going to copy this after you decrement it. Counter and decrement. It should be this. So the assert we want to write here is that counter before this is so bad. Before decrement should be equals to counter after decrement plus 1. So we can put the message here that invalid counter. Right? Yeah, this should be double. So this is 10. This value here, it should be 10. And when we decrement, this would make it what? Counter is now equals to 10 minus 1. And then we are expecting this to be 9. You understand? So 10 should be equals to 9 plus 1, right? Yeah, 10. It should be equals to please give me a minute, sorry. These people understand. So yeah, we still have the should panic here. No, you should not panic. Test decrement. Yeah, let's check this. Let's check this and see what happens. Yeah, we have this. Some other assert you can do is counter before. I'll just copy this. Should be equals to what? 10. We have the same message, right? And then the counter after decrement should be equals to what? 9. Why am I using 1 equals to? This is not mathematics. Yeah. So let's run scab test again and see. So all our tests are passing. So looks like the other thing we need to do is the next thing we need to do is to make sure that the events are emitted. So we can come here. Let's just let's grab this. Let's grab this so we can reuse it. Let the expected events. This one should be counter. And this should be counter decremented. No. Stop doing this. If you look at the counter decremented and it is emitting the new value, so this should be counter after decrement, right? Let's check. Let's check this. Yeah, the tests are still passing, which means everything we are doing the right thing. And the last function that we need to test is reset. We want to test reset. Now, there are lots of things going on here. The first thing is that the amount must be greater than 0, the amount we are passing, and the caller must be the admin. So I don't know. Let's test for the failure first. Fn test reset should panic with invalid caller. So we are putting a should panic message here. And then we have expected. What's the message? Only admin. Yes, sir. Only admin can reset, right? So yeah, let's start with let's do this. Let's do this and then for reset. Let's just do contract dot reset. Let's pass it. Let's pass in an amount of 1. Yeah, we're expecting this to panic. For some tests that you're expecting something to panic, you can just do it, those tests as long as it is it panics earlier. The test can be like very short. You understand? Like in this case, we are just calling reset. All right, we are calling reset. This will panic. Now, this will panic. Yeah. Only admin can reset. Now, I think maybe like let's say we actually want to call this with the admin. The natural question that will come up is, how can we call this with the admin, right? Or, yeah, how can we call this with the admin? So, yeah, let's do a test to call things properly. Fn test reset. Let's test the workflow for reset when we are doing things. So we have the leads contracting. That's the first thing. Now, we are creating this contract. Yeah. The counter value is 10. Initially, it is 10. Now, we want to make sure that the caller is the admin, right? How do we do that? Now, there are some things that are useful. They are called cheat codes. You understand? And the way the cheat code work is you can use it to cheat the caller. Like you can use it to like you want to call a function, and you can say you are calling with this particular address, right? You can use it to cheat the caller. You can use it to cheat the block timestamp. You understand? You can use it to like cheat a lot of things. And Foundry has all these useful functionalities. So we want to call reset. Normally we just do contract dot reset, right? Let's put in an amount of 1. Yeah, but the thing is, we want to figure out how to use the admin because the admin must be the one calling this function. And this is the admin address. So there are some things from Foundry. They are called start cheat, caller address, and then we have the stop cheat, caller address. We can use these two. There is also a simple command that is to just do it at once. You understand? That's just cheat caller address, right? So yeah. What we do before calling the reset is we say cheat caller address. We pass in the contract address. That's the first thing, dot. And then we pass in the caller address. And then we pass in the span. You understand? If you look at this, so the cheat span, instance of cheat span, identifying the number of contract calls with the cheat applied. You understand? So this is how many times you want it. You can just use target calls and put 1. Yeah, we only want to do it once. We only want to cheat once with this. So let's test this. Let's test this. We will run into an error, but the error will be, it won't be that it will be invalid caller. So you can see the failure data here. It says U256 sub overflow. That is something is overflowing. You understand? In this case, it is saying subtraction. Just to simplify this message, it just means underflow. You understand? And what's causing that? If you look at this contract is supposed to take token from the caller and send it to this contract. Now, the token amount that we put here is 1, right? Now, when you call this transfer from ERC20, the first thing it will do is it will check, okay, this is just the interface. The first thing it will do is it will check the approval, like, because for you to call transfer from, the owner of the wallet will have to approve that, okay, I allow this contract to spend from my fund. But now the approval is 0. You understand? So the first thing we are supposed to do here is we are supposed to approve this contract to spend from the user's balance, right? Now, yeah. Now, let's do this. Let's do this. So before calling any of this, the first thing we need to do is we want to approve, right? We need to use Open Zeppelin. Let me say use Open Zeppelin. No. Token. ERC20. Yeah. I want to use the Open Zeppelin interface, dispatcher. Coming. We have this here. Yeah. Let's copy this and use that instead. So let me reduce this so there is more screen space. So the first thing we need to do is we want to approve, right? We want to do approval that that the user is allowing the contract to spend from their balance. So let's start with doing the token dispatch. Let's create the token dispatcher. equals to ERC20 dispatcher. What is this thing? Oh, okay, it is IERC20, sorry. And then we say the contract address. Now, what is the contract address? We have that here. Oh, so light is gone here. We'll have to stop sharing the video, guys. So, yeah.
Yes, sir.
So, sorry, guys. It's a bit messy for me today. So sorry. So we have in the lib.cairo, we have already declared the stack token address. Let's just put it here at the top where we define our constants, right? Yeah. Let me remove this. Let me remove the extra line. That's from start for FMT. Now, if you look at this address, this is actually the address for the stack token on Sepolia testnet for Starknet. So we want to pass the stack token here. So we'll be able to call the functions on an ERC20 contract on this. So the first, we said we want to make approval. We want to say token dispatcher dot approve. We want to approve contract dot contract address. And we want to approve, the amount we want to approve is just 1. If you look at this approve, it's saying the spender and the amount, right? That's what we want to do. But with this also, we have to make sure that we are calling with the admin, right? We have to make sure we are calling the token contract with the admin. So let's put this cheat caller address at the top of it and say token dispatcher.contract address, right? Because if we don't do this, it will fail. So what's the step we have here? And also if you are using in the DApp also, before you can spend users token, you see in that case they have to sign to transaction. But Starknet account abstraction actually made this easy because you can do it or you can batch transactions together. But normally, let's say in the EVM ecosystem, you have to first of all sign this, approve. Then after they approve, then you can now call the function on the contract to do whatever you want it to do. So let's check this. Let's check this. Okay, so we still have U256 sub overflow. We still have U256 sub overflow. Yeah. And the reason for this is because this account, this admin, it has no balance. You understand? It doesn't have stack token. So what do? Let's get an account that has stack token. Hello guys. Can you guys hear me? Please, if you can hear me, send a thumbs up. All right, thank you. Sorry, a call entered and I'm using my phone for hotspot. So sorry about that. So let's so basically what I'm doing is look for the stack token. This is the page. Look for a wheel that has some balance and use it. You can use it as the admin address, right? Now, let's check. This will still fail. And we'll get to the reason why this will still fail as well. Let's run it. It will still fail. And it's failing with the same error. Now, the reason why this is failing is because whenever we run this, it is running it in a dev net environment. You understand? But now we have an address that has some tokens on Sepolia, on the Sepolia network for Starknet. But then we are testing locally. Nothing is happening. You understand? Nothing is happening at all. So that is where our fork testing will come from. You understand? The fork testing will now be sending the transaction right to Sepolia testnet. So it is very important if you want to do for maybe for mainnet or for testnet, it's very important for you to have this configuration. So this is 2.snforge.fork. So we are doing for Sepolia, you put the RPC and the block ID.tag, it must be latest. You understand? So how do we test this? How do we run this fork test? It's simple to do. You just come here and say fork and put the tag that we have in the scarp.ton of our Sepolia. Let's try this. Let's try this and see what happens. So this would take longer because it's trying to connect to the internet and do something. You see that it's not happening locally anymore. You understand? It's actually trying to connect to the Sepolia blockchain and mock using this address, like we are calling this from this address. Keep in mind that when we do this fork testing, the balance will not reduce on the Sepolia or mainnet, but in this environment, it will simulate it. You understand? Does anybody have any question regarding this? Any question? Yeah, no question. So, let's do one thing. Let's do one thing. Unfortunately, I can't stay here for long. It's they're about to close the gates. Let's do one thing. I've sent the GitHub link. I sent the GitHub link. Today is Thursday. If anything is unclear, I'll send a message in the Starknet Africa Telegram. We can hold another call tomorrow. You understand? Do you guys agree with that? Do you guys agree with that? If you agree, please send a thumbs up. Yeah. So I'm very sorry. I'm very sorry about this. Yeah.
Right now, it's only Ramat that is responding. Can we have other person so that we're sure that you guys are going to join the call? Okay, we have two more persons. Okay. Mm. All right. Or Truth, could you possibly like get access to the other workspace tonight, or it's not possible? All right, Truth, can you hear me? No choice. Oh, he's out of the call already. Or anyone can drop their question regarding test in the Telegram channel. Yes. Yes, that works too. Uh, let me reach out to him, please. Just give me some minute. Let me reach out to him. So, what's his name again? Okay, so guys, I just got a call with him. So he's saying that he can access the other workspace, but that's going to take him about 10 minutes. Can we wait, or would you guys want to wait until tomorrow to finish the call? Left to me, I want us to like finish everything today, because today's supposed to be last class, last session. So what do you guys think? Please, I'd like to hear your, let me post this.
I'm back now. Yeah. So yeah, thank you. Sorry if sorry guys. So yeah, basically we've been able to test this. Yeah, but there are some things we still need to test with research, right? Whenever we research, we're adding a certain amount. So this amount we are putting one, you understand? But we know that the stack token is scaled by 18 zeros. So let's do that. Let's put something here and call it scale. Let's call it token decimal. You understand? Which will be a U64. That would be 1, 2, 3, 6, 9, 12, 10, 18. Right? 1, 2, 3, 4, 5, 6. Yeah, this is the let's say the amount we want to use here. Let's call this the amount, which will be 1 times scale factor that we have here. You understand? Or is this really necessary? Mm. If you ask me, it's not necessary actually. The reason why it's not necessary is because we already have a decimal function on the token dispatcher that we can use. So we can just say amount equals to 1 times token dispatcher dot decimal. So this is saying the decimal is not there. Why? Let's try it. You should try an error. Right. Yeah. Well, let's use scale factor. I mean, they're all the same. Let me just revert the code. Yeah. So we have the amount, let amount equals to 1 times the scale factor. Yeah, that we have here. It is saying identifier not found. Oh, sorry, token decimal. I'm a little bit confused right now. Yeah, sorry about that. So 1 times token decimal. This operation doesn't change the value and can be simplified. Okay, yeah. Let's just say it's the token decimal. Or we can do 2 times. Yeah. So let's put this amount here. That's the amount we are approving. And then put the amount here. You understand? Okay, this is expecting a type U256, but it's saying U64. My bad. Let's use U256 here. Yeah. Everything is green now. So I don't think we are changing anything more for us to run it. Another just the assertion that we need to do, right? So what happens in this reset function? The first is we are doing X here. Then we are transferring again. We need this. So what do we need to test? We need to test token transfer, right? That's 1. 2, we need to test what? Changes. And 3, we can test sorry, since when was I gone? I didn't know the network. Uh, tonight is a little bit. Yeah. Can you guys see my screen? Yeah. So yeah, the first thing is the token transfer, state changes, and then the event emission. So for the token transfer, we need to check the balance before calling reset, and then check the balance after calling reset. So let's say admin balance before equals to token dispatcher dot balance of the admin, right? And then we do the contract balance too. Contract balance before we call reset. That should be token dispatcher dot balance of the contract dot contract address, right? Now, after we call reset, we want to check this balances. Let's write variables for the after. And then for the after for the contract. Now, the first assert we have here is that the admin balance, who is losing money, it's the admin. The admin balance before should be equal to admin balance after plus amount. Yeah, sorry. So we can put an invalid balance. Yeah. That's the first one. Then the second one is the contract balance before. Yeah, the row will have to reverse here. You understand? This will have to be contract balance after should be equals to contract balance before plus the amount, because the contract is the one getting the money. So we are sending from the caller to the contract. So the admin balance is supposed to reduce, right? If this logic is not fine with you, maybe we can rewrite it to use minus instead. What do you guys think? Yeah. Yeah, you can unmute if you have something to say regarding this. So yeah, invalid balance. Now we have checked the balance. The next thing we want to check is the state, the reward amount, right? And the counter. So let's do some asserts. So we have done the first one. Yeah. Check token transfer. Then second one, I want to assert that the contract dot get reward amount. The reward amount should now be equals to this amount that we define. So this should be invalid amount in the case that, yeah. Sorry, yeah. And lastly, no, not lastly. So we also want to check the counter, get counter, that should be equals to 0. Invalid counter, right? And lastly, we want to check the event emission. So for reset, yeah, there are 2 events. Yeah, this is like a very nice test case that we can do. And there are 2 events. So we have the counter reset event and the counter and the contract funded event. So let's say let expected counter reset event equals to event counter reset counter reset, and then when we reset it, the value should be 0, right? And the second one, let expected contract, funded event should be equals to event contract funded Now it is funded with this amount. We don't need to pass anything. Yeah. Normally you can do this you can do it like this, but since it's the same, you can just leave that. Now, are we spying? No, we are not spying. So let's start spying from here. Equals to spy events, right? And then we come here, we say spy dot assert emitted. Yeah, we have this array. And the first one, I believe all these events are on the counter contract. Yeah. So we have the contract address. And then the first event, which event is coming first, is the counter reset event. Yeah, because you have to test them in the order that they happened. So let's check this. I'll just copy this and duplicate it here. Yeah. So we have test reset here. Just to recap, let's start this from the beginning again. All right. So the first thing we did is we deployed the contract. We started spying, yeah, for any event that we can catch any event that happens. Then we have our token dispatcher here. What's the reason for the token dispatcher? Can anybody remind me the reason why we have the token dispatcher? Anyone? You can unmute. You can unmute. You can unmute if you are still here. Yeah. So I guess we'll just continue. The main reason why we have the token dispatcher is just so that we can approve. We can approve. We can approve. The admin can approve the contract to spend from its balance, right? So yeah, and this is a fork test as well. Then we are doing all this check to check the balance before and the balance after. We are calling reset here. This is where the main action is happening. So, and then we are checking that the balance is, yeah, that the user balance is reduced, yeah, and that the contract balance increases. Then we check the state changes. This is where the two state changes are happening. We are updating the reward amount and then setting the counter to 0. And lastly, we are checking the event emission, right? So let's run this and see what happens. Let's see. Yeah, so yeah, the tests are passing. So that means that we did everything correctly, and the logic, it is everything is going as expected, right? Yeah. So does anybody have any question? If you have any question, you can ask me. Yeah. I think we missed one test here, which is that this amount must be positive. Yeah, let's do that. Let's do that as well. Yeah. This should panic. No. With this expected. Yeah. FN test reset should panic with invalid amount, right? So basically we can do the whole thing. We can do it the same way. And this is reset. Yeah. We just put 0 here. Put 0 there. Yeah, let's run okay, only admin. Yeah. So the reason why we are getting this error is because firstly is this checking this admin, and we are not marking the admin as the caller here before checking the amount is positive. So this failure will happen first. So we have like a very simple fix for that. We just need to do this. We already have it here. Let's just bring it here. Yeah, before calling it. And let's try again. Yeah, the fork test is taking some time. Let's wait. Yeah, all the tests are passing. So basically that's how you can write Starknet test. One other thing I want to say is you see that when we are doing this test, we are basically running everything. Let's take for example that we don't want to run this test that is taking too long. We just want to run a specific test. Let's say this one that we just added. Yeah. You can just do scarp test and just put the test name there, and it will run that alone. You can say one test is passing instead of running all the 7. So you can check the GitHub. I created an SN4 resource, which is short, and you can use it like a cheat sheet so you don't need to dig into documentation and read all these several pages. And just look at this document on the way to do testing on Starknet using Starknet Foundry. Yeah. So yeah, thank you guys. I think that's all from me. If there is any questions, so please shoot. You can send it in chat. You can unmute and ask questions now. Yeah, thank you. Okay. Yeah. Yeah. I can't get any question from any other person. Izolu had to send you. So just checking that things.
Truth, are you done? Sorry, I can't hear you. You're muted.
He's done, man. He's done.
Okay. All right then. Thank you guys for joining to this class. Thank you, Truth, for the session. So we're going to be sending out the recordings by tomorrow, and further instructions on the official end of the boot camp. Yes. So thank you so much, guys, for sticking around till this time. Yes. Please and please, it's very important that you build your project and you submit your project, because that's also going to be like a criteria for graduation. Yes. So I don't know, do you guys have any questions? Yeah, thank you. Any questions? Even if you have any questions, you can always drop them on the tutors, sorry, the hackathon channel or Starknet Africa channel, wherever. Thank you so much, guys, and have a lovely weekend. You can just look out for emails tomorrow and next week. Next week is going to be the official graduation week. So thank you so much. Thank you, Truth. Thank you for your time. Have a lovely weekend ahead. Bye. Bye.